Okay, two more speakers. Robert Simmon. Robert is a cartographer and science communicator who specializes in visualizing satellite imagery. I should say we were introduced by R.J. Andrew. Is that right? Yes. He has decades of experience working with remote sensing experiments and entrepreneurs, helping share their research and products with the public. Along the way, he's designed some of the most widely viewed imagery of our home planet, featured in National Geographic, the New York Times, and the original Apple iPhone. Robert, thank you for joining us.
Thank you for the introduction. As Tom mentioned, I have decades of experience, about 20 years working for NASA, another 10 working for a company called Planet, which when I joined was a startup, went public, and I'm sure you've heard of NASA, but Planet builds and operates a constellation of Earth observation satellites in downtown San Francisco. And I am currently freelancing / unemployed. So if anybody finds this interesting, let me know. And so today I'm going to talk about the ways that data journalists use satellite information and satellite imagery in the course of their work. And I'll start out with a little bit of history, and then sort of break down 3 different ways that I think that journalists will typically use the data. One is context, where it's really just helping readers to understand the larger picture. And then documentation, which is showing events or showing the consequences of an event. And then investigation, where a journalist is actually using the data as a tool to perform additional analysis and report on the story. And so for the first 30 or 40 years of the availability of satellite imagery, which started in the early 60s, it appeared in media mainly for 2 things. One, to either report on the hardware or to report on research that was being done with the data by other people, so largely government institutions, or for weather forecasting. And so, of course, evening news, you would very commonly see like a loop from a geostationary satellite. And so these are just 2 examples of this. This is a very high resolution image of a ship under construction in the Soviet Union. And this was a leaked classified image from what was called the KH-11, which was the most advanced of the US reconnaissance satellites at the time. And then the right is a 3D version of a hurricane in a story in National Geographic about a cycle of warm and cooling waters in the Pacific Ocean. And then in 1999-2000, this began to change. And there were a few things that were influencing this. One was faster computers, wider availability of software, things like GIS. Open source came a little bit later. And the opening up of archives of government-controlled data sets. And the other thing that happened was the beginning of commercial remote sensing and commercial high-resolution imaging. And so the images that were available started to be on the human scale where the vast majority of journalism is done. And so this is an example of the first light from a satellite called IKONOS from 1999. And it's a 1 meter per pixel resolution, which previously had been the domain of those big government reconnaissance satellites that you saw the other image from. And that image was published in a story in the Washington Post, which had, I thought, this really enlightening quote in it. It says, 2 weeks ago today, a satellite whirled above Washington on its way around the Earth and shot photographs from 400 miles up that could change the way some people do business. And she listed a whole bunch of sort of canonical examples of commercial remote sensing, including counting pools, which keeps popping up but is really stupid. But anyhow, it's this. There are these themes that you see over and over again. But she didn't mention anything about this changing journalism at all, but it really has had a huge impact on how some types of reporting are done. And so this is an early example of a collaboration between CBS News and Amnesty International, again, using that commercial satellite information. This is from, at the time, a company called Digital Globe. They're now called Maxar. On the left is an image from 2004, and on the right is an image from 2006. And this is showing the destruction of a village in Darfur, Sudan. And so it was part of an effort by Amnesty to track what was otherwise a very hard to follow ethnic conflict in South Sudan. I believe it was Sudan at the time and is now its own nation. And so that leads us to now, and I'm just going to give you some contemporary examples, most of them from the past couple of years, starting with context. Again, it's to help readers understand the larger picture rather than being the focus of the story itself. And so this is another image from a geostationary satellite, which if you saw the whole thing would be most of a hemisphere, on a story about how fire is used in the Amazon and often gets out of control. And you have this burning season. And so this, rather than showing the impact of an individual fire, shows the entire Amazon basin and how smoke spreads across the whole region. And also sort of giving you a sense how large the impact is. So it's really a good fraction of South America. Another example, this one is from NPR. And now we're actually setting things in space, in time, as much as we are in space. So this is from 1964, the Aral Sea, which at the time was the 4th largest freshwater lake in the world, and is now essentially non-existent. And there were 2 rivers feeding into the sea, extensively diverted for irrigation, mostly for cotton. And the Aral basically doesn't exist now. There's one small section where they built a dam that remains and some ephemeral water that rises depending on how much water there is in any given year. But really there's almost nothing left of it. This is an example from the Washington Post where they used a satellite mosaic and then treated it more like it was a map. So reducing the colors, reducing the detail, and then overlaying other information on top of it. And this was in a story about repaving a road that had been built in the 1970s and allowed to decay. And leading from Manaus in the center of the Amazon rainforest to a town on the southern border. And the story was not about the larger picture, but about how when you revitalize this type of infrastructure, you will impact the area of the forest along the road and how that tends to lead to a lot of forest degradation. But because they use satellite imagery as a basis, you see the really up-to-date information of where there's towns, where there's water, where there's deforestation already. And then this is actually one of my favorite examples. This is using a sea ice data set. So it's not an image at all, but it's data of sea ice concentration. So in any given like 20 by 20 kilometer pixel, what percentage of that is covered in ice? And it was in a story illustrating the Franklin expedition, which was in the mid-19th century to look for the Northwest Passage. I see heads nodding. So they didn't make it. The climate was a bit different 170 years ago. Ships got frozen in the ice. Entire expedition was lost. But there have been follow-up missions since then, including one from 2023 with a smaller boat, and that can now navigate through the Northwest Passage because there's much less ice. And the ice was used as a cartographic element to show sort of what the conditions were like. Although, you know, it was an expedition that took, I think, a couple months, and this just shows like a weekly average or something like that. So again, it's not the focus of the story, it's just background. And then this example is from the New York Times. We were talking at lunch a little bit about the New York Times graphics and cartography department, which is, I think their cartography department is like a dozen people, and the full team's about 50. And this was in a story about saltwater nearing the New Orleans infrastructure for their drinking water supply. And it's an area of the world where the boundary between land and water is not at all distinct. And so the cartographer used satellite data. They actually just cite Copernicus, so I'm not sure if it's radar or if it's imagery, but they colored water, mostly green, teal type colors, and then land is brown shades. But there's really, like in the landscape itself, there's no distinct boundary between land and water in the color palette. And so it just gives you this sense of what the landscape is like in a way that I think a more conventional map could not do. Okay, now we're going to move on to documentation. And this is a bit more literal, where you're showing an event or you're showing its effects. And so this one's mine. This is an image from when I was working at Planet that is showing the aftermath of a Houthi drone strike on Saudi oil infrastructure back in 2019.
Sure they're not running
And there's actually an entire subgenre of smoke plumes from satellite imagery. It's just one of those things that is really obvious and really striking when you take this view from above. And so it was picked up by Reuters and on dozens of newspapers, again, including the New York Times. You can also show change in this type of documentation. So this is an image, again, from Planet after I had left, featured in KQED, our local NPR affiliate. This is January 6th. So this was the day before the Eaton fire started. So you're looking at the San Gabriel Mountains in Altadena in the northern part of LA. You'll notice that the forests and other vegetation here is bright red. That's not because it was burning or damaged. It's because this image is using wavelengths of light that we can't see. And it's this particular wavelength is very sensitive to vegetation, the presence of vegetation. It's about as reflective as snow in this particular wavelength. And that's in the red channel, so everything's bright red. And that's one of the unique capabilities of remotely sensed imagery is we're not limited by only what we can see. And so it's using these extra wavelengths of light to provide more information. 2 days later, this is in the midst of the fire. And so the smoke plume is, again, this subgenre, but it's obscuring most of the fire. But you can see some of the burn scar, as well as a little bit of Altadena. And those bright red spots are actually where there's active fires or smoldering debris. Another example of fires, and this one's not an image at all. This one's purely a map and purely based on data. Using NASA and NOAA data where there are thermal infrared detectors on satellites, and these are used to map where fires are. And so this is a week's worth of data from the first week of this month, showing what at the time were a pretty intense fire season. It was the second most intense ever. I think they've tamped down a little bit, but at the time was a very early start to a very big fire season. And this was featured by the BBC. And then this is from the Minneapolis Star Tribune, about the same time period. And instead of showing the fires, they're showing smoke. Where the data is used to initialize the simulation, and then a forecast is made and saying, okay, over the next few days at 6-hour time steps, this is where the smoke is going to be. And it both shows the power of the technology and is a nice animated GIF that I can show. Another example, again, of using pure data, and this is data that is fed into a model, is something called a snow depth map, showing the epic 2023 snow year after several pretty dry years, and in fact, several pretty dry decades. And this is showing the snow depth in California on June 1st of 2023 compared to 2022. And, you know, in the 20th century, you would actually typically see something in between these two extremes. But, you know, even at fairly low elevations in the Sierras still had snow in 2023. In 2022, only the very highest elevations had any at all. And this is much more typical of our current climate. And this was an image, a map from the New York, Los Angeles Times. Yeah. Although there's another DC storm that gets that name too. So this is another, again, data, not image, showing a marine heat wave in the North Atlantic in between the British Isles and Iceland. And this is from the Financial Times. And I think this is interesting, not necessarily because of this map by itself, but showing another way that this data can be transformed. And we can start to look at time series. And so this is the average temperature of that box every day for the past probably 25 years, if it's the data set I think it is. And so you can see in 2025 in May, there was a spike of highest sea surface temperatures ever for that time of year. And then in 2024, you had the highest ever in that location in a little bit later in the summer. And so this is transforming the data to tell a richer story than you would get just by using an image or even just a map. And then my final documentation example is from texty.org.ua. They're a group of data journalists working out of Ukraine, and they've done a lot of tracking of the impact of the Russian invasion. And this was using a completely different technology called synthetic aperture radar to look for the signature of oil spills from tankers that have been damaged in the Black Sea. And so on the left-hand side of this map is Crimea, on the right-hand side is Russia, and the Crimean Strait divides it. And so there's a lot of ship traffic that goes through there, and there's activity with interdiction and things like that going on. And then finally, and this is definitely the most complex and maybe the most interesting applications of satellite data, is as a tool for investigation, where the journalists are performing additional analysis to draw a novel conclusion and not just documenting an event or providing context. Another New York Times example, this one I think was from Monday, showing not only the impact of the penetrating strikes on the Fordo nuclear facility in Iran, but they went back in time and using this archive as a time machine to show why those particular locations were picked. And this was a couple days before the DoD press conference that described the whole mission and was explaining this very thing. And so the journalists, collaborating with their sources, were using the data as this key component of, well, why did they hit those particular spots? And it's because there were ventilation shafts that led down to the halls where the nuclear enrichment is going on that are key weak points. And so that's where you would hit with the penetrator, so it had a better chance of actually damaging the facilities. And of course, the Iranians knew this, so they tried to cover it up. And so by 2011, that's all been smoothed over, and you wouldn't know if you didn't have the archive. Another example of monitoring a conflict, but this is a little bit second order, and this is something called a pattern of life analysis, where you're looking at things over time and you're looking at regular imagery to see for changes. And this was a Reuters report looking at the expansion of an explosives factory in Eastern Russia. And a typical day, a typical work day in 2023 looked like this: empty parking lot. 2025, not only is the parking lot expanded, but it's full of cars. And so that's an indication of activity at this previously sort of low-level plant. And of course, this is an effort to keep their war material coming. This is an example, again, in the Ukraine-Russia conflict from Bloomberg, in a story about how Russia's attacks are degrading the energy infrastructure in Ukraine. And this is actually a little bit more of a blend of context and documentation to start with, where this is Kharkiv, Ukraine in autumn of 2021 versus the autumn of 2024. And so you can see this huge decrease in the amount of light. And this is a calibrated instrument. And so this isn't just like pictures and that's the difference in exposure. That's actually looking at the intensity of the lights. But the meat of this story was doing a damage assessment with other types of imagery and then comparing it to the location of energy infrastructure in OpenStreetMap. And then using that correlation to estimate how many energy facilities had been damaged by the Russian attacks. And so sort of what the larger impact is on Ukraine. Another example, this one from Le Monde, it's a damage assessment where they were looking at the percentage of structures in each of these districts that was destroyed when Israel had an incursion into Lebanon to degrade Hezbollah after the anti-Hamas operations in Gaza. Sort of the intense phase of that had pulled back. They also invaded Lebanon. I believe it was actually at the same time that the Syrian regime collapsed. And so sort of, depending on how you look at it, taking advantage of the opportunity or securing their borders. And then finally, this is an example, another one from Reuters, of this very in-depth investigation to look at places where you might get outbreaks of zoonotic disease, particularly from bats. And so most new diseases in the human population come from animals, like COVID-19 almost certainly came from an animal. We don't know exactly which one and likely never will, but it's probable that it wasn't, and it very likely could have been a bat. And bats are also the source of Marburg virus and Ebola virus, and another one called Nipah virus that is prevalent, not really prevalent, but has sort of periodic outbreaks in India and Bangladesh. And so for this, what Reuters did is they looked at the locations of previous outbreaks and then made an inventory of, I think they said 58 different parameters, most of which you can measure by satellite, things like vegetation cover, tree loss over the past 20 years, temperature, population density, things like that. Fed that all into a machine learning model and then did a search to find where there were similar areas in other parts of the world. And so it's a global map of the possibility or highest risk areas for the outbreak of a zoonotic disease from bats. And in this case, it's part of Southeast Asia. Okay, so from this, I think you can draw a few conclusions. One is that even 25 years on past the introduction of satellite data into the narrative, and the advent of tools like Google Earth, which are ubiquitous, satellite imagery remains really striking and really engaging. And so it's a way to draw in viewers and attract viewers' attention. It is also a extremely and uniquely qualified to do global investigations and other wide area investigations. You just can't do it with people. You can't do it with sensors. You really need this global perspective that only satellites can give you, and likewise time. Because again, they're calibrated instruments and you can compare 2000 to 2010 to 2020 to 2025 in ways that other technologies are very limited in. And then finally, it's a unique tool for investigative reporting where you take the data and develop a hypothesis and actually build models and work much like a scientist does, but do it in the context of reporting rather than in the context of research. So thank you very much. And if you have any questions, please let me know.
Thank you, Robert. We got time for one question, if anybody has one. Okay, John.
Yeah. Oh, no, I know I've looked at their data, and they weren't just doing Sundays. Yeah. Yep. I have looked at their dates in specific, and there's more to it than that. And I know that they didn't just do, yeah, weekends. But that's critical. Like it's like low tide, high tide is another thing you got to watch out for. So.
Great. Thank you. Thank you very much.
Can I just quickly follow up on that?
Yeah.
It's just how do you check the data?
What do you mean, like carefully? Well, so the revolution is you can get the source data. You can go to Maxar, you can go to Planet, you can go to NASA, and you can get the data and then download it. And the journalists have the skills to analyze it